Alright, this is the quadratic functions review. I'll start with number 1. What are the zeros of the trinomial? So the zeros are solutions. Super easy. It's already equal to 0. So I just take each of my individual factors and I set them equal to 0. 2x minus 3 equals 0. And x plus 5 equals 0. I'm going to solve this. Add 3. 2x equals 3 divided by 2. X equals 3 halves. Or if I subtract 5 from both sides, x is equal to negative 5. So my two solutions are x equals 3 halves and negative 5. Number 2, a little bit trickier. It's still a quadratic, obviously, because it's x squared. But this one is not in factored form. So the first thing I need to do is either factor it, or maybe I can try to graph it and get the solutions. If we factor it, what we did in class was we made the big X. At the top of the big X, we did the A term times the C term, so that's negative 18. And the bottom was the B term, 7. So now we're looking for two numbers that multiply to negative 18 and add to 7. That's going to be 9 and negative 2. So I can take these two terms here and split this middle term into that. So I get 6x squared plus 9x minus 2x minus 3. And that's equal to 0. Factor both parts. The first two terms have a 3x in common. So I'm left with a 2x plus 3. The next two just have a negative 1 in common. So I've got a 2x plus 3 left over. So that leaves me with factors of 3x minus 1 times 2x plus 3 equals 0. So 3x minus 1 equals 0. Add the 1. 3x is equal to 1 divided by 3. X is equal to 1/3. And the second solution, 2x plus 3 is 0. So 2x is equal to negative 3. So x is negative 3 over 2. If we graph it, we get 6x squared plus 7x minus 3. We get a picture like that. Go to menu, analyze graph. We're looking for a 0. Move the slider left and right. We get negative 1.5, which is negative 3 halves. And if we do that again, analyze graph, 0, left of my other one, right of the other one, and I get positive 0.333, which is 1/3. Number 3, factor the expression and then explain how to use the factors to find the zeros. So if I want to factor this, x squared plus 2x minus 24, make the big X again, negative 24 at the top, 2 at the bottom, because it's 1 times negative 24 for the top and just positive 2 for the bottom. Multiply to negative 24, add to positive 2. That's going to be 6 and negative 4. I could split the middle term here just like I did above, but it's not necessary. When a is 1, these two guys right here are automatically going to be the factors, so I just get x plus 6 times x minus 4. And then the explanation of how to use factors to find the zeros, set the factors equal to 0 and solve. Number 4, given the zeros are at 8 and 6, write the quadratic function in factored form. So factored form is exactly what we have here on number 1. So we just said that the zeros are the solutions to factors. So if I want 8 to be a solution, I could have started with a factor like x minus 8, because if I set that equal to 0 and solve it, I get 8. My other factor would then be x minus 6, and that's equal to y, so that is now a function in factored form. 5, same thing. Factors of negative 2 and 7 are at the quadratic function in factored form. That's going to be y equals x plus 2 times x minus 7. because negative 2 plus 2 is 0, and 0 times anything is 0, and 7 minus 7 is 0, and 0 times anything is 0. So either way, it's equal to 0 when I'm all done. One more. Given zeros at negative 4, negative 6, write the quadratic function in factored form. Again, x. So which one of these A, B, C, or D correctly gives you an answer of 0 when you plug in either negative 4 or negative 6 into them? So negative 4 plus 4 is 0, so that's going to work. But negative 6 minus 6 is not 0, so A is out. B is out because we already said that negative 4 plus 4 worked. C is out, so D has to be it. Negative 4 plus 4 is 0. Or if I plug in a negative 6 plus 6 is going to give me 0. So D has to be the correct answer. 7. What's the equation of the following graph? Probably the easiest way to do it, start with factored form. Y equals, I'm looking for two factors. We know that factors are the zeros, and the zeros are where it crosses the x-axis. So my zeros are at negative 2 and positive 3. So my factors are x plus 2 and x minus 3. And then what I need, though, is I need to know about some value that might be out front of this, some a value. So to find a, I just need to pick another point on the graph, and this 0, 6 point looks like a good one to pick. So if I plug that in for x and y, 6 equals a times 0 plus 2 times 0 minus 3. So 6 equals a times 2 times negative 3. That's going to be negative 6. So 6 equals negative 6a, which means that a has to be negative 1. So my equation then is going to be y equals negative 1 times x plus 2 times x minus 3. Alright, number 8. Does the graph have a minimum or maximum? What are the coordinates of the vertex? So I don't even need to graph this to figure that out. We know that the a value here tells me whether it goes up or down. Since a is negative, the graph goes down. So since the graph goes down, we have a maximum value. And this graph happens to be in vertex form, which is a times x minus h squared plus k. And the vertex, when we're in vertex form, is always at h, comma, k. So when I look at that, my vertex has to be at negative 6, because it's always the opposite of whatever my h value is, because it's minus h. So it's minus 6 and then negative 4. Number 9, rewrite the function in standard form. We're going to do that by expanding this guy out. Standard form is ax squared plus bx plus c. So as we do that, we get negative 4 times x plus 3 times x plus 3 minus 5. That's what it means to square something. And so I get negative 4 times x squared plus 3x plus 3x plus 9 minus 5. So negative 4 times x squared plus 6x. I'm just combining these, plus 9 minus 5. And then distribute. So negative 4x squared minus 24x minus 36 minus 5. Combine my like terms, and I'm going to get f of x equals negative 4x squared minus 24x minus 41. In that standard form. Does that function have a maximum or minimum? So again, I look for a. A is negative, so it has a maximum because the graph is going down, and the coordinates again are going to be hk. So I've got negative 3, negative 5. Moving on to number 10. The equation given by the height of a kangaroo jump as a function of time. What is the maximum height the kangaroo reaches? So maximum height is going to be the vertex. This is not in vertex form. So I'm going to graph it. So negative 9x squared plus 35x plus 4. I get this guy. And my vertex is all the way up here. So we need to know what the highest point is. I'm going to do menu, analyze graph, maximum, left side, right side, and I get that. And this ordered pair is 1.94 comma 38. So we know that the input is always whatever we're dealing with in the original problem. In this case it's t, and then the output in this case is h. So the height that the kangaroo reaches is 38 feet. It happened to take him 1.94 seconds to do that, but the height is 38. Number 11, the cross-section of a boat is given by the equation x squared minus 12x plus 27, x and y are measured in feet. Determine the width of the boat. Well, what we can do to figure this out is we can imagine this being on a coordinate plane, and the width is the distance from this point to this point, which those would just be my x-intercepts or my zeros. I'm going to go back to my graph. I'm going to graph this function. And so there's my boat. And so what I want to know is where this point and this point are on the graph. So I'm going to do menu, analyze graph. I'm looking for the zeros. The left bound, right bound, here's 1 0. The other 0, analyze graph, 0, left bound, right bound. I get 9. So I've got zeros at 3 0 and 9 0. So one of my points is at 3, the other one is at 9. So the width of the boat is just 9 take away 3, which is 6 feet. Determine the depth of the boat. Well, we've got the water level again, but this time we want the depth of the boat, which is going to be down here, which is this point right down here at the bottom of the graph, which again is my vertex. I'm going to analyze graph. This time it's a minimum, left bound, right bound, and I've got a point at 6, negative 9. So if side to side, that was the width, then up and down has to be the height. So my height is this negative 9 number, but height can't be negative, so the depth of the boat is just 9 feet. 12, graph the function and find the equation of line of symmetry, vertex, and x-intercepts using any method. So any method, well, I'm going to go to my graph, and I'm going to type in x squared plus 2x minus 8. There's my graph, but I would like to be able to graph it accurately. So I'm going to make a table, and looks like I can maybe pick some points. So if we make a table of values over here, x, y, looks like negative 4, negative 3, negative 2, negative 1. Zero, 1, 2. So at negative at negative 4, you get 0. Negative 3 is negative 5. Negative 2 is negative 8. Negative 1 is negative 9. And it looks like it starts to repeat. So it's 0, back to negative 8, negative 5, and 0. So we'll plot some points. Negative 4, 2, 3, 4, 0. Negative 3, negative 5. negative 2, negative 8, negative 1, negative 9, and we get that. There's my graph. Find the equation of the line of symmetry. So the line of symmetry is this vertical line that goes through the vertex. And so it shares an x value with that vertex. So that is x equals negative 1. My vertex itself is at, if I look at the table, negative 1, negative 9, and my x-intercepts are here and here, which were at negative 4 and 2. 13. Use a graphing calculator to sketch the function. Does the graph open up or down? What is the y-intercept? What is the vertex? We get 2x squared minus x minus 3. So the x-intercept is where it crosses the x-axis. For that, I'm just going to do a trace, and it gives me right there 0, negative 3. So first of all, it opens up. What is the y-intercept? That's at 0, negative 3. What is the vertex? So menu, analyze graph, minimum. And my vertex is at 0.25 and negative 3.13. Does the vertex represent a max or a min? That's going to be a min. It opens up and graph the function. It has an x-intercept at 0, negative 3. A minimum value at 0.25 and negative 3.13. So, just sketching it, looks like my x-intercepts are at just past negative 1 and about positive 1.5. So somewhere around here and there. And it's a super ugly graph, but we're just sketching it, so we're fine. Compare the graphs of 4x squared minus 3 to 1/2 x squared plus 1. Select all that apply. So I'm comparing g of x to f of x. So g of x, when I move from g to f, I notice that my a value goes from 4 to 1/2. What we learned in class was that the bigger the a value, the steeper the graph was. So g, if g looks something like this, we'll call this g of x, then f of x is going to be somewhere out here, because it's a smaller number, and the smaller the number, the wider the graph is. So f of x is wider, and then as far as shifted, we have a negative 3 and a positive 1. Those are my y-intercepts. So my first graph was at negative 3. My new graph, it crosses at positive 1, so the whole thing had to have been shifted up. 15. 4 bowls with the same height are constructed using quadratic equations. Arrange the bowls from widest to narrowest. The widest graph is going to be the one with the a value closest to 0. So that means that my fractions are going to be the widest. We just have to decide what's a smaller number, 3/4 or 1/3. 1/3 is smaller, then 3/4, then 3, then 9. And we don't care about positive versus negative, we just care about the absolute value of the size. Alright, 16. A person tosses a water balloon. The situation is represented by the function negative 2t squared plus 11t plus 5. State the domain and range of the function in the context of the situation. So we have a big issue with that in class. Context of the situation, you have to think about what's actually happening. So let's look at the graph. So I've got negative 2x squared plus 11x plus 5, and I get a picture that looks like this. So first thing we need to talk about is the fact that in context, so domain is going to be the x values or the inputs, which in this case the inputs are the t's, which is time, and then output is h, which is the height. So what do we know about time? Time can never be negative. So when we look at this graph, all we care about are values on the graph between where time starts at 0 and where time ends when it crosses the x-axis, which is over here somewhere. So the domain of this graph is going to be 0. So remember, bracket for the beginning, 0. And then I'm going to use analyze graph. I'm going to find my 0, lower bound, upper bound, and it looks like I'm at 5.92. So my domain goes from 0 seconds to 5.92 seconds. And then my range are my outputs. So in this case, it's going to be my height. Well, my height can't be less than 0, so my height starts also at 0. And then from there, it goes to whatever my maximum value of this function is. So I'm going to find the maximum, menu, analyze graph, maximum, left, right. My maximum is at, looks like 20.1. So my range goes from 0 to 20.1 feet in this context. 17, given the graph of a quadratic, state the domain and the range. There is no context behind number 17. It's just a graph. So when I look at this, I can move side to side however much I want to, because of these arrows here and here. So my domain for this function is negative infinity to positive infinity. Note the parentheses, not the brackets. Remember, brackets mean that it ends at that point. Parentheses means it doesn't. Range. So my range, again, I've got these arrows, which means it goes down forever. So that's negative infinity. But then when I go up, the highest I can go is to positive 1. So my range goes from negative infinity until positive 1. And because my graph ends at 1, we get a bracket on that side. Finally, 18. The height in meters of a ball t seconds after being thrown is modeled by that function, describing in words the meaning of h of 3. So h is the height, 3 is t, and t stands for time. So this is the height of the ball at 3 seconds. What is the maximum height that the ball reaches? Well, I'm going to go to my graph. I'm going to put in the function negative 2.5 x squared plus 9.8 x plus 2, and my maximum height is going to be up here, menu, analyze graph, maximum, left bound, right bound, 1.96 and 11.6. So which one of those is my height? Well, this is the time, so that means that this is the height, t, h. So 11.6 meters is the highest point that my ball reaches. And finally, C, what is the height of the ball at the instant it's thrown? Well, the instant that it's thrown, time is 0. That's the immediate second that it's thrown. So I'm looking for what's the height when the time is 0? So I just plug in 0, negative 2.5 times 0 squared plus 9.8 times 0 plus 2. This becomes 0. This whole thing becomes 0. So my height at 0 seconds is 2 meters.